So the new homework due dates, the 4.2 is due today. And then 4.4 will be due on Monday because that's when we cover it. Test 6 is Wednesday, November 11th during class time. That's the day before Thanksgiving. And so Matt and I, there might be an option for you to take it the day before. We just need to discuss that. We'll tell you tomorrow if that will be an option. Again, if you're not currently passing the class, please get in touch with me and discuss your option for taking the alternate final. Okay. All right, so I'm gonna go ahead and start this. We may not do the whole thing, just depending on how much time. We may have to skip like the last 5 problems because they're over piecewise functions, which we haven't really talked about. We'll talk about those today, but you should be able to do them, but it just depends on if time permits. You may skip those. Two of the people that logged on first aren't showing up. I wonder what happened. Come back. They're coming back. If you can log on in the next 30 seconds, that would be great. And if you absolutely cannot log on, please follow along. Even, odd, or neither. Okay, so if you look at this, it is neither because we're looking at exponents. There's a 4, there's an exponent of 3. This is an implied 1, and this would be x to the 0. So that it's got both even and odd exponents, so it would be neither. Even, odd, or neither. Okay, it is even. If you look at the exponents, there's a 4, there's a 2. A constant always counts as even because it's like 5 times x to the 0 power. If you've got a polynomial that has all even exponents, then it's even. And if you've got a constant, that is considered even because it's like x to the 0. Even, odd, or neither. I hope y'all can see that. It's kind of small.
Oh, I don't know if you remember that 4.1 homework makes them like add either a 0 or a first degree term to make it odd or even. It's kind of a weird question.
What?
it's in the written homework.
Oh.
Not in the.
Yeah.
On the paper, it's like
most of them did that fine.
Okay.
Yeah.
Because it's kind of an odd question. It's like kind of
they did
not like anything they've gotten.
They got it. The people that did it, almost all of them got it right.
Yeah, I had one person come to office hours. So
that was a weird question. I agree. Okay. And one thing I wanted to ask you about, Matt, too, and I counted this right for them. One of the questions said, draw a graph that has no local maximum or minimum or something. Anyway, they had an endpoint on there. And I don't think that would technically, I think we have to have totally continuous graphs is what I'm saying. And people were putting endpoints on their graphs. Is that, what do you think? You see what I'm saying?
I'm not sure I visualize
it. I'll show you later, but yeah, I didn't count it wrong because we hadn't really discussed that, but anyway.
They always find like really creative ways to mess up. It's really great.
Yeah.
Like I'm always really like, it's way more creative than like doing this stuff, and I don't think they realize it, but.
All right, so this one, if you notice that we've got the 0, 0 here, so it could be odd or even. And then if you look at -3, it's matched with +3, and -1 is matched with +1. They're opposite, so that means that it is odd. If the signs are opposite, that means it's odd, and there has to be a 0, 0 origin also. So this would be an odd function. Complete the table. I know that's kind of hard to see, but only one of this is, I think only one of these is an odd function. So basically it's pick which one of these is odd. Okay, so basically you could count out anything that doesn't have the origin. So you could have X'd out the yellow and the green right off the bat because they're not passing through the origin. So the only ones that are left are the red and the blue, and the blue is the one because it has the origin, and then the signs are opposite, so it would be odd. So the green one couldn't be odd because it passes through 0, 1. And the same, this one could not be odd because it passes through 0, 1. Complete the graph if we want an even function. Okay, so even means it has symmetry with respect to the y-axis. That means if you fold it over on the y-axis, it would overlap exactly. So that would be the gold one. Let's see, the red one, the blue one is nice and symmetric, but if you notice, it's symmetric around x equals 2, not the, it has to be symmetric with respect to the y-axis. Glad y'all didn't pick the red or the green. Local maxima. Okay. Okay, so remember endpoints can't be a local maxima. So that the 4 is out because an endpoint cannot be local. Maximum, and we're talking about the top in a region like the peak of a mountain. So that's this one right here, and it's the y value. So it would just be 1. 1 is the only local maxima. 4 would not be because it is an endpoint. Absolute maxima. Okay, most of y'all got that. All right, this has no absolute maxima because that arrow tells us that this keeps going to infinity. Infinity, you can't count that because it just goes on and on forever. So there is no absolute maxima.
But what about the number 4 though? Does that not, that doesn't count?
Well, this, no, because this, it's not, okay, so 4, it stops there, right? But the graph goes way past 4.
Oh, so
You
it
see what
has
I'm
to be the
saying?
whole thing.
Yes, yes.
Okay.
Yeah. Local minima. I don't know where I got that -4. Okay, so local minima, anywhere you have a valley, that is not an endpoint, that would be a local minima. So it would be negative 6.5 and negative 12.5. Absolute minima. Good, most of y'all got that right. The absolute minimum would be the absolute bottom of the graph, where it bottoms out, the very, very lowest point on the graph. And it's the y value, so it would be negative 12.5. Which of these is true for this polynomial? What did y'all pick? Y'all picked 5. Okay, so let's look at this. Here's the graph. Here's the equation. So how many humps do we know that this is going to have? How many turning points?
Should be 3, right?
Yeah. And the very end, will it be pointing up or pointing down?
Down.
Down, right. If it's negative, the very end of the function is always going to be pointing down. So we know it's pointing down, and it's got 1, 2, 3 humps, right? Now these might be the same level, but that would still be an absolute maximum. Or one might be higher than the other one, in which case that would be the absolute maximum. Right? Definitely won't have an absolute minimum because both ends will be pointing down. It will have an absolute maximum. The graph will have both. It won't have both. what might be the graph of this polynomial. Which one might be the graph? Okay, good. So we know it's third degree. So how many humps is it going to have?
2.
2. And that's also positive. So the very end would have to be pointing which direction? The very end.
It should point up.
If it's positive, the very end has to point up. So this one has 2 humps, but it's pointing down at the very end. This one has 1, 2, 3 humps, so it can't be, it's not cubic. This one has 2 humps and it is pointing up. So that's why this is the one to pick. This one has 2 humps, but it's pointing down. Actually, I think well, no, they're different, but. Minimum degree and the sign of the leading coefficient for this graph. Okay. So if you look at this, if you count the humps and add 1, that would be the minimum degree. Another way that you can tell is count 1, that how many times it crosses the x-axis. But we'll talk about that. That's something we'll later. And then we know it's negative because the very end is pointing down. So add 1 to the number of humps and then look at what's happening at the very end. And that will tell you what the leading coefficient is going to be. Which of these functions has a negative leading coefficient and an odd degree? Good, most of you got that. Let's look at this. Okay, so negative means it's pointing down at the end. So the only possible answers would be B and D. Then count the humps on B. There's 2 humps, and if you add 1, that would make it 3rd degree. So that's the answer. If you look at this one, there's 1, 2, 3 humps. If you add 1, it would be 4th degree.
Oh, so when you said odd degree is you're saying not odd. Because I was
Right.
thinking odd, it goes through the origin.
Right, odd degree is different
Odd
than being an
degree
odd
is
function.
different. Okay. See, I
Right,
still need to watch that.
yeah.
Yeah, so when we say odd or even just by itself, that's the symmetry thing. When we say
Right.
odd degree, that's the largest degree in the thing.
Largest exponent, right?
So it can't have other degrees when we talk about odd degree or even degree. It could have multitude of degrees in that thing that are lower, right? And each
Okay,
one of those
now
lower
we're-
degrees, I did it in a little lecture, but with the Desmos, if you go in Desmos and play around with it a little bit, that probably like really help you like get a little bit of a handle on these things probably.
This time we want a positive lead and an even degree. Okay. So the only possible answers are A and C, because a positive leading coefficient, an even degree. Well, this one couldn't be. Positive means the very end is going up, but this one would be 1, 2. If you add 1, it would be 3. Here, the very end is going up, and if you count 1, 2, 3 humps and add 1, that would be 4. So the only possible answer would be C, because it's both positive because the very end is going up, and it is 4th degree because the minimum degree would be 4th degree because it's got 3 humps. I got picked A. Yeah, you got the positive part if you picked A, but you didn't get the even degree. What is this? Describe this polynomial. Okay, so let's see. Only one of y'all got this. No, 3 of y'all got it. That's good. So let's look at it. First of all, this isn't an even function, because to be an even function, it has to, the y-axis would have to be its axis of symmetry, which it's not. What else was the other choices? Positive lead, we have to have that. So y'all, if you pick positive lead, that's good. Odd degree, if you count here, there's just one hump. So it's going to be even degree. So it's a quadratic function with a positive lead. That's the only one that would appropriately describe that graph. Does anyone have a question over that? Which one of these statements is true about this lovely function? Okay, we got all over the place here. Okay, so it is, the degree of this function is even. If it was an even function, it would have, it would be symmetric with respect to the y-axis. If it was an odd function, the ends would be going opposite directions, number one. And if you counted the humps and added one, you would get an odd number. The degree of this function is definitely not odd, because to be odd, it would have to pass through the origin. And it does not pass through the origin. So it's not an even function, because definitely not symmetric to the y-axis, right? It is of degree that's even. Both ends are pointing up. And if you count the humps, 1, 2, 3, 4, 5, and add 1, that would make it 6th degree. So that's the one that's right. Any questions about that? Which of these is false? Don't pick the green one. We haven't really talked about that. I forget. Sometimes I get mixed up what we've talked about, what we haven't. It does have 3 real solutions, because there's 1, 2, 3. Have we talked about that yet? Okay.
No, we haven't talked about real zeros yet.
I didn't think so. I'm like, okay.
4, 4.
Okay.
I think I've talked about it, but we haven't officially talked about it.
We've talked about it, but it hasn't officially been talked. Yeah. Okay. So if we look at this, it has no absolute maximum. That's the red. That is true, because this thing goes on to infinity. So it definitely does not have an absolute maximum. The other one that was wrong was it has a positive leading coefficient. Well, no, that was right. That's true too. We'll go on to the one that was false, right? So that is true. Positive leading coefficient, because if the very end is going up, that means the leading coefficient is positive. And this one, of course, is wrong because it has a negative leading coefficient. If it had a negative leading coefficient, the very end, the tail end, would be going down. So to tell if something's positive or negative, you look at the tail end of the function. If it's going up, it's always going to be positive. If it's going down, it will be negative. Minimum degree and the sign of the leading coefficient. Okay. So the red one says minimum degree is 3. If you count the humps and add 1, then it would be 4. That's what you have to do to find the minimum degree. So if you look at this, the minimum degree, 1, 2, 3 humps, add 1, that would make 4. So that means it's even degree. And then the tail end is pointing up. So that means it's positive. Which equation would most likely match this graph? This is pretty much the same question. It's just a little bit different as the last one. Okay, so if you look at this, we said that it was 4th degree, right? 1, 2, 3, add 1 makes it 4th degree. So the only functions that are 4th degree are the red one and the blue one. And then we also said it was positive because the very end is pointing up. So that would mean it has to be the red one, because that's between these two. This is the positive leading coefficient. So the green one, it can't be, first of all, it's, if you count the humps and add 1, that it has to be 4th degree. It's definitely not negative. And then this one too, count the I'm just gonna add 1. Degree 5, negative lead, 4 turning points, and 2 x-intercepts. And it is 5. Okay, so the reason, this is tricky, guys, but I'm just telling you, I did that on purpose to trick you. The reason that this one, the yellow one, would not be the answer is because this guy is going up, right? So it's going to cross the x-axis again right here, right? I didn't draw it crossing it, but it would cross it because it's got that arrow. So this would be 1, 2, 3. It would be crossing the x-axis 3 times. So that's why that one's not a good one. This one, it only crosses the axis. It does cross the axis twice, but it's not negative because the very end is pointing up. So the only one that has 2 x-intercepts and is pointing down would be the green one. Okay, I'm going to skip these last ones because they're what we're going to go over the homework today. I want to make sure we have time to finish the homework. So I'm going to skip.
Drawing those graphs, there's not really like one sort of correct way to do it either. When they give you those like properties that you have to follow and then draw the graph. Yeah. There's multiple ways to draw those things. So.
Which makes it really fun to grade. We're going to be doing the piecewise functions today, so. Okay. Yay, Michael. Aurora. And Hunter. Good job, you guys. And Gabby and Timothy are runners up, so that's great too. All right, so I did, I uploaded the second half of this so onto Blackboard. So if you want to, you can pick that up. I am going to, let's see, part 2. So this is part 2. I don't know. Just a second. So we need to do 17 and 19 where we finished off. So number 19, we already identified that as being a And number 17 was B. And I think we already, well, let's just go through it. So we've matched the equation, identify the turning points. So the turning points on this one would be 2, 16. Turning points are going to be in blue. And negative 2, 16. And 0, 0. And then estimate the x-intercepts. So the x-intercepts are where it crosses the x-axis. So I'm going to do those in red. So the x-intercepts look like they're 2.8, 0, 0, 0, and negative 2.8, 0. And then any local extrema I'm going to do in green. So local extrema would be, again, 216 or 16 and 0. This would be a local max and also an absolute max because it's the absolute top of the graph. And this would be a local min. But there is no absolute min because it keeps on going down. Okay, so on this last one, 17, the turning points are negative 3, 20, 22, 27, and 1, negative 5. Local, the x-intercepts are, let's say negative 5, 0, 0, 0, and 2, 0. The local max is this one. There is no absolute max. And the local min is here. There is no absolute. Okay, so we finished those guys. Any questions on those? Okay, so these are the ones that you can draw and doesn't have to look like mine at all. So I want everyone to try to draw number 55, degree 3. How many humps will it have if it's a degree of 3? How many humps? That's what you need to ask yourself first. How many?
2.
How many? 2, right. And then if A is positive, what does that mean about the very end of the graph?
It goes up.
Yep. And what does it mean to have 3 real zeros? Anybody?
Crosses the x-axis 3 times.
Yes. Or touches it. It has 3 x-intercepts. Doesn't necessarily have to cross it. It can bounce off of it. It can be tangent to it. So what I do when I'm doing these is I always start at the tail end to make sure it's going down. So I go, okay, I know the thing's going down. And that's the first thing I draw. And then I know it has to have 3 zeros and 2 humps. So there's 1 hump and that's 2 intercepts. And then, whoops. No.
Shouldn't this one be positive?
Oh, thank you. Yeah. Positive is pointing up. And it's going to cross the x-axis 3 times. And notice it'll have 2 humps. So your graph should look something like that. Doesn't have to look exactly like that at all. Anyone have something that looks wildly different than that they want to check? Okay, so 56, let's just do it for fun, even though it's not really part of the homework. 56 degree 4. So how many humps?
3.
Yep. And then 4 real zeros. What does that mean?
4 x-intercepts.
Yep. And then A is less than 0. So which way does the very tail of the graph go?
Go down.
Yep. So again, I usually start with the very end, make it go down. And then I know it has 4 x-intercepts. So 1, 2, 3, 4. And then I count to make sure I have 3 humps. 1, 2, 3. Yes. So they could not give you a problem that says degree. Well, they could, but you just have to say you can't do it. If they said like degree 4 with 5 zeros, that's not going to happen. So they're not going to give you a scenario that you can't do, or if they do, just say no. All right, so on 57, this one's kind of super easy. A linear function. What does a linear function look like?
Line.
It's just a straight line.
Straight line. And A is less than 0. So which way is the straight line going to be going?
So these are like approximate, like it's not have to be perfect because we don't have
No,
everything.
everyone's can look totally
Yeah.
different. Yeah,
So it just has
Yeah,
to
yeah,
meet the
yeah.
criteria. Okay.
right.
Yeah, so it's like a slope going from left to right, it would be going
That's
down.
right, going down, right. So you
Yeah.
can draw it anywhere you want, yeah. Just make sure it's a line that's pointing down. Okay, now these are kind of fun if you're like me. We're doing 87 and 93. Okay, so I am going to first do this piece. So I go X and Y. And what should this look like? Part of a what?
Reverse parabola.
Part of a parabola, right. That's going downward because it's negative. But okay, so now I'm just going to pick the points right here between -3 and 0. So -3, -2, -1, and 0. And y is equal to 4 minus x squared. So 4 minus -3 squared would be 4 minus 9, which is -5. 4 minus -2 squared would be 4 minus 4, which is 0. 4 minus -1 squared, if you square -1, you get 1, and that would give you 3. And 4 minus 0 squared is still going to be 4. And these, remember, we've done these before. What kind of dots will be on the -3 and the 0? Open dots or closed dots?
Open.
Open. Mhm. So I'm going to go ahead and graph that piece. -3, -5. Now I'm going to put an open dot there. -2, 0. -1, 3. And, oops. And 0, 4. That's an open dot too. Nice, right? Okay, now let's do the other guy. The other one is x squared minus 4 when x is between 0 and 3. Again, these are going to be, this one is going to be a closed dot because it's got the equal sign. This one will still be an open dot, right? Because it's got it doesn't have the equal sign. So here we have x, and our y value is equal to x squared minus 4. So I'm going to go 0, 1, 2, 3, open dot here, closed dot here. 0 squared minus 4 would be -4. 1 squared minus 4 would be -3. 2 squared minus 4 would be 4 minus 4, which is 0. And 3 squared is 9, minus 4 is 5. So I'm going to plot those points. 0, and again, it should look like a parabola or part of a parabola. 0, -4, open dot, 1, -3, 2, 0, 3, 5. Something like that. Now these should look, yours should look like this. This is not arbitrary. Exactly what it should look like. Okay, 93, before we start 93, I want us to envision what each piece of this graph is going to look like. So what is this first piece going to look like? What is the 2, what is, if I have y equals 2x, what is that going to look like? What kind of shape? That's all I'm asking, shape. Your choices are a line, a parabola, square root function, absolute value function, piece, whatever. So what is 2x? Y equals 2x. What shape would that be? What figure would that be?
I mean, if it's just, sorry.
Well, go ahead.
Will be a line.
A line, right. Is it going to be a line that's pointing upward or a line that's pointing downward?
Upward.
Upward, right, because it's positive. Okay, so in my brain, I know I'm going to have, this piece is going to be a line that's going upward, okay? What about if x equals -2, or f of x, y equals -2? What is that going to look like?
It's a horizontal line that
Right.
intercepts the y-axis at -2.
Right, it's going to be a horizontal line, exactly. Okay, so this piece I know is going to be a horizontal line. Finally, the last piece, what's this piece going to look like?
I would say a parabola.
Part of a parabola that does what?
is-
Opens upward or downward?
Upward that
Right.
intercepts the y-axis at -2.
Okay, so all I did right off the bat is said, I just want to envision what each piece is going to look like. So I kind of have an idea that I know that I'm doing it right or wrong. So I am going to do the 2x first. And it's from -5 to -1. -1. And I know that I have a closed dot on the -5 and an open dot on the -1, right? Stop me, guys, if I'm doing something you don't like. So 2 times -5 is -10. 2 times -4 is -8. -6, -4, -2. So let's graph that piece. -5, -10. -4, -8. -1, -2. There's the first piece. Looks like what we thought it would look like. Now let's do the second piece. The second piece is y equals the constant -2. So we said it's going to look like a horizontal line. So it goes from -1 to 0 with a solid dot on the -1 and an open dot on the 0. So no matter what number we have in there, it's going to be paired with -2 because it's constant. So -1, -2. Ooh, we fill in this dot. And then 0, -2. Ooh, this is not, I don't know why they would do this to me. It's just that little piece just right there. And then finally, this last piece. Y equals x squared minus 2 from 0 to 2. 0, 1, 2. And there's closed dots on both ends here. So 0 squared minus 2 is -2. 1 squared is 1, minus 2 is -1. 2 squared is 4, minus 2 is 2. So we have 0, -2. So we fill that in. 1, -1, and 2, 2. So it looks like a piece of a parabola. Are y'all feeling good about that?
Yeah, I'm not gonna be too picky with like drawing these exactly accurate with like the parabola. Just make it so it's not completely straight. Make sure I see a little
Yeah,
bit.
yeah, me too. Okay, diminishing returns. So these are kind of fun. Okay, so diminishing returns means that you reach a point of saturation and then you start losing money or you stop producing what you want. So in this case, it says F is defined by this, and it calculates a fish harvest in thousands of tons when X hundred fishing boats are used in a region. Okay, so before we get started here, what is the 2x going to look like? And anybody like the first one?
The 2x, I mean, if it's y equals 2x, that's just gonna be a line,
Right, it's going to be a line that goes up, right?
goes
Okay.
up, and
And
it's
then
gonna
what
be,
is what
sorry.
is this guy going to look like?
Wow, I'd say a parabola with some other humps on it.
No, just a parabola, right?
I
So
guess
it's
not.
quadratic, right? Because it's got that square.
Yeah,
And which way would it be pointing?
it's gonna point down.
Right. So, all right. So we have a general idea of what this is going to look like. Now, somebody, please, this is what I'm asking you to do. Somebody, please figure out the vertex of this parabola, and I'm going to ask you about it later. Remember, x is equal to the opposite of b over 2a, and then y is equal to, you plug that in to the function. Okay. So someone use the vertex form to find the vertex, please. And we'll talk about it in a minute. All right, so now usually when, or almost always, when we're talking about an application problem, we're almost always in the first quadrant because we're not talking about negative numbers of boats or negative numbers of fish. So I'm just going to draw the first quadrant. And these are my fishing boats. And these are my fish. Okay, so I'm going to do this first. First, I'm going to do the 2x when x is between 0 and 4. And I think this is interesting. I think this is a typo. See how they have the equal sign in both places? That shouldn't be that way. I mean, it should be in one or the other. So I think they just did a typo. And I'm going to make it be in the first one. So 0, 1, 2, 3, 4. Solid dot, solid dot. It really doesn't matter for this problem, but that bothers me a lot. So this is 0, 2, 4, 6, 8. I don't know how many dots I'm going to need. So I'm just going to do a bunch. So 0, 0, 1, 2, 2, 4, 6, and 4, 8. And I'm going to go ahead and label that 4, 8, just because. Okay, now I'm going to do the parabola. Did anyone find the vertex?
Yeah, it's 12.
What
Or
is it?
812, my bad.
8, 12?
Right.
Okay, hold on. Yep, that sounds right. The vertex is going to be 8, 12. And you can find it by using the vertex formula. Okay, so now let's do this. So x and y equals to negative 1/4 x squared plus 4x minus 4 when x is between 4 and 12. Okay, since I have this 1/4 x squared, I'm going to pick numbers between 4 and 12 that are divisible by 4 because I don't want fractions. I don't want to deal with them. So I'm only going to pick 4, 8, and 12. And I'm going to have an open dot on 4 because this was a typo, and a closed dot on 12. So if I take, someone do this for me, negative 1/4 times 16, that would be negative 4, right? Plus 4 times 4, which is plus 16, so that would be 12. Minus 4 would be 8. Does everyone agree with me on that?
Mhm.
Now, what would the number 8 have to be paired with? Because someone already figured it out. Have to be paired with 12, right?
Okay.
And if you plugged 8 into this equation, it would be 12. And then if you plug 12 in here, I forget what this comes out, probably 8 again. I'm thinking, because if this is the vertex and we've got symmetry going on, I'm probably going to get an 8 here if I'm doing it right. But if you plug 12 in, you should get that. So now let's plot those points. So 4, 8 actually just is right there. So it's part of the graph. So, 8, 12. I'm going to pretend like that's right here. And then 12, 8. And we know it's a parabola. Great. So this is what it looks like. So what does this mean as far as the fishing boats go? What's happening here? Where do they start? Where do they stop catching more fish and start actually?
Once they get to like 800 boats, then it starts to go down.
That's right. Right. So it says find the absolute maximum and interpret the result. Okay, first of all, it says find f of 3. Okay, so what is f of 3? Equals to what?
So that'll be y is 3 equals 3.
So f of 3 is 6, right?
So 6. Okay.
We figured that out when we were plotting this. And then it says find the absolute maximum. So that would be, the absolute maximum would be 12,000 tons of fish. And that happens when there are 800 boats. And after that, it's diminishing returns. After that, the more boats you get out there, the less tons of fish will be caught. Okay, we're almost through. I will post all of this for anyone that has to leave us, but this one's super simple. Let's take about 2 seconds. In the figure, the monthly average temperature in degrees Fahrenheit from January to December in Minneapolis, which thank goodness we don't live in Minneapolis, is modeled by this polynomial function, where x equals 1 corresponds to January and x equals 12 corresponds to December. Estimate the turning points. So what do we think the turning points are? What do y'all think? What does that look? What does this point look like?
First one would be 111.
Yeah, I'm going to put 1.111. Just and then this one is a little bit over. This one looks like it is. What does it look like? What does this guy look? What does it look like? What do you think it is?
772.
Yeah. Okay, so interpret the turning points. So what does this mean? What does this mean? What is the 1.1?
It's a rise.
Well, what month are we? This is the month, right?
Oh, oops, yeah. February, January?
Yeah, right. It's early February, right? You're gonna have the lowest temperature, right? Or whatever it is, Minneapolis. Okay, so that means that in early February, Minneapolis will have its lowest temperature of the year, which is 11 degrees. Okay, and then what does this guy mean?
In July, they'll have their highest temperature.
Right. And that's it. So tomorrow we will, please look at your tests. Make sure you can ask any questions and I'll go over anything you want on the tests. And then we'll probably have time to do a little mini review of everything.
That's tomorrow?
That's tomorrow.
Okay,
We're going over the test and then we're going to kind of look at everything we've covered so far, just in a compact form.
Yeah, we only have like one more section and then we're ready for the test.
Yeah.
basically.
yeah, I was looking at the syllabus. I think test 7 is the last one before the finals start.
Yeah, but this is test 6. Yeah. And then test
Oh, I'm
7.
sorry, I mean the upcoming test.
No, we
Sorry.
have one more. The one before Thanksgiving is the last test before the final.
Yes, yeah,
Yeah.
test 7.
Okay.
And-
All right, you guys have a great afternoon. I'll be here if you need me.